But what I want to do is I want to return to our conversation, because we were beginning to enter a interesting point of conversation, and that was going to be how we can actually involve ourselves with this idea of proper propagation of our layer 2 information associated with our... So what we want to do is we want to really start looking at a concept that Cisco was first to come up with and was probably the first to want to try to abandon. And that's called VTP. VLAN Trunking Protocol. VLAN Trunking Protocol is the go-to tool when it comes to propagating information associated with VLANs. In fact, I really wish that they would change the name. I mean, VTP Trunking Protocol, VLAN Trunking Protocol, implies it has some kind of control aspect associated with the formation of trunks. And it doesn't. It's going to be and exists solely for the express purposes of propagating VLAN information. Now, if I want to propagate VLAN information, I have a number of ways that we can do this. And the easiest way for us to be able to walk through this is to just bring up the gear and start talking about it. Because what you've seen thus far is you've seen me go through and do configurations where I've set up VLANs manually. So notice here, show VLAN brief. I have the VLANs that we've created, VLAN 10 and 20. We did not create VLAN 1, it existed on all devices. Now when we roll over to Cat 1, do show VLAN brief, what we see is we have those VLANs created here, 10 and 20. However, but when I go down to Cat 3, which is trunking to Cat 1, interestingly enough, show VLAN brief, what we're going to find here, do show VLAN brief, is that these VLANs do not exist. Now, this is really funny and really interesting, because first of all, what I want to do is I want to illustrate something. What I'll do is I'll just create the VLANs. So I'll come up here and I'm going to create the SVI interfaces that we need to use for testing. So I'm going to create interface VLAN 1, which already exists. That'll be IP address 10.10.0.9.255.255.255.0. No shut. Interface VLAN 10, IP address 10.10.9/24. No shut. Interface VLAN 20, IP address 10.10.20.9/24. Now, no shut. Let's take a look at this. Show interface trunk. Now, what I want to do is I want to illustrate something here. So when we go through, I want to see, can I ping 10.10.0.7? Can I ping the VLAN 1 interface located on Cat 1? Yes, I can. Can I ping 10.10.10.7? And what we're going to find is I can't. We're also going to find that I can't ping 20 either, VLAN 20's interface. But we created the SVIs, and unless we got something wrong with regard to our sums, I'm going to go ahead and just say 27 just for the sake of testing. I'm going to repeat it 2 times instead of having to wait here for the whole time. So unless we did something wrong here, show interface trunk, we should have linking. But do we? So notice we have FAO 21 and 22. We're trunking, we're negotiating still, .1Q trunks, VLAN 1 native, and we could reach VLAN 1. And we could reach VLAN 1 because they were the only VLANs that were allowed in our management domain. VLAN 1 was it. 10 and 20 is missing. Well, the rationale behind here is that when it goes in and we set this up, VLAN 1, if I come in here and type show VLAN 1 or show VLAN brief, what we're going to find is this VLAN 1 exists already. VLAN 1 and every interface that we have is part of it. To include, it's being trunked across our interfaces themselves. So if I come up here, the ones that are in the trunking state, show interface trunk, we see VLAN 1, which is our native VLAN in this instance, is running across those links. Now, what will end up happening here is the problem, and the thing that a lot of people lose track of is the fact that when you create an SVI, the system does not create the VLAN for you. So in order for me to make this operational, I need to create those VLANs. VLAN 1, 10, VLAN 20, exit. Now, none of those configurations will take until I exit the command out. So now, if I come up here and say end, and repeat those ping tests, Obviously, I'll be able to ping 1 because we didn't change anything, but let's see if I can ping the VLAN 20. With 2, I might not be able to. Let's see, can I ping 10? Ping 10, 10, 10, 7, VLAN 10. Let's see what happens across 5 ICMP attempts. And just to reiterate, we have a successful ping. Now, what took so freaking long? Well, it was difficult, or it took a long time for us to be able to come in and get this up and operational, is because what happened was we had to wait for spanning tree. Now, we're not ready to talk about spanning tree, but what we're going to find is there's going to be tons and tons of disadvantages to the current and default operational aspects of spanning tree that we have running on our switches. But right now, what I want to do is I want to limit our conversation to the idea of this concept of VTP, VLAN Trunking Protocol. Now, what we're going to find is that we have 4 devices, Cat 1, Cat 2, Cat 3, and Cat 4. We have trunks between 2 and 1, 4 and 1, and 3 and 1. Now, that means that we need to understand how we're going to propagate information, because creating VLANs manually can be a pain in the butt. All right? So what we're going to find here is that when we want to start creating the VLANs, and guys, I want to keep the conversation about spanning tree to a minimum until we reach that section, but yes, you are correct. We have about 50 seconds. Depending on what state that we're operating in. If the interface is just coming up, there will be 20 seconds of blocking, 15 seconds listening, 15 seconds learning, adding up to 50 seconds. But if the interface has already come up, we're going to have a delay of 30 seconds. And that's all going to be part of the idea of VLAN spanning tree. And what we're going to do first of all is talk about VLANs and VTP propagation, and then we'll move directly into spanning tree. So in this idea of having this loop, or this configuration, what we have is we have 3 devices. We have Cat 1, we have Cat 2, we have Cat 3, and we have Cat 4. And we have some type of interconnectivity. I'm just going to draw these in. They're not representative of the individual links, it's just showing connectivity. So when we look at this right now, I've got VLANs, VLANs on this one, VLANs on this one, so it's going to be 1, 10, and 20. Now, when I take a look at this one, I'm going to have 0 VLANs, but VLAN 1, because, again, we inherit VLAN 1 by default. So let's take a look at that exact device. So we'll cut over to Cat 4, and what we'll do is we'll show VLAN brief. And what we're going to see is we have VLAN 1 and VLAN 1 only, show interface trunk. We're running these, and the idea is that we're running them. All VLANs are allowed, but the only VLAN that's active is VLAN 1. And that's because only VLAN 1 exists on this device. So what I'm going to do is I'm going to show you just how simple it is for us to make configurations associated with VTP. All I need to do is just enable the process. Now, it's not an enable VTP. It's actually not much of anything. The only thing that we really have to do to turn VTP on is to give it a domain. In fact, I'm going to type show, or do show, VTP status. And what we're going to see here is we're going to see some information regarding how or what capabilities our devices have. Notice we have VTP version 1.2.3 is our capabilities. We are currently running VTP version 1. Now, the main thing that I want to look at here is this idea of the fact that we have no VTP domain. So when we go in and we start taking a look at how this is going to be interconnected and how it's going to be operating, before we can run VTP, we need to be able to have a domain. The domain is going to be critical because it's going to be the domain where we actually regulate the sending and receiving of control plane information such that we can actually bring VTP up and let it do its job. But before we go so far as to do that, I want to say debug, let me see, is it debug? Hold on just one second. Show. No. Like I said, I jump up between devices way too often. Statuses, counters, that's what I'm looking for. Now, when we go through and we start looking at this, what we're going to see is we're going to see statistics associated with VTP information. It's going to tell us things with regard to what type of summaries, any errors that we're going to be encountering. Notice it's also going to give us statistics associated with VTP pruning, something we haven't yet talked about, but something that's pretty important. Now, when we go in and we start working with our different configurations, like I said, the only thing that we need to be able to do is to enable VTP to operate. To do that, all I'm going to do is I'm going to say config T, and I'm going to say VTP domain, and I'm going to give it a name, IPExpert. Now, this domain name is case sensitive. All right, so if I have a capital letter, it needs to be capitalized everywhere. Cisco is famous for messing with us and also substituting zeros for O's and capital O's and things along those lines. So be careful how you have things configured. Now notice what ends up happening is we have a VTP domain name change, and it changed to IPExpert. Now let's cut down to Cat 4, because remember, Cat 4 had no VLANs. Show VTP or VLANs brief. Well, now all of a sudden Cat 4 has 20 and 10 and 1. Now the reason being here is that the default operational mode is server. So even over here on Cat 4, show VTP status, what we're going to find is that I have a default operational mode of server. So I could create VLANs. So what we'll do is let's create a VLAN. Let's say config T. We'll say VLAN 600 exit. Now the moment I come up here and I go to Cat 1, what I'm going to see here is I'm going to say show VTP, show VLAN brief. What I'm going to find out is 600, do show, will be created. So what we've got is we've got a method of being able to exchange information between all of our different devices. Now, let's look at the nature of this information. So Cat 1, show, do show, VTP status. Now, in the confines of the VTP status that we're going to be looking at, what we see here is pretty straightforward. Notice we have the capability of supporting up to 1005 VLANs natively in the configuration. Also notice that here we have a number of existing VLANs. There are 8 of them in total. In fact, what we can do is we can scroll up right here and we can see the 8. 1, 2, 3, 4, and 5 that we inherit that exist by default on this particular type of device. So 102 to 105 exists for the purposes of some very special applications like fiber distributed infrastructure, things that we're not going to need to work with in the confines of routing and switching. So for us, we need to pay attention to the fact that we support up to 1 to 1005 VLANs. Now there's going to be modes and ways for us to get around this. Now we also have this idea right here. We have the configuration revision number. The configuration revision number is a level of believability. All right. Now, what I want to illustrate here is I'm going to show you a problem. So what we'll do is we'll come in here and we'll say interface range FA0, and what I'm going to do is I'm going to say no. I'll say FA0 19 to 24. What I'm going to do is I'm going to shut this off. I'm going to shut all those interfaces down. So I just killed all of these individual links that I have illustrated above my head. And what I'm going to do is I'm going to come in here and create some more VLANs. I'm going to say VLAN 99, VLAN 100, VLAN 101, VLAN 102, and I'll say VLAN 103, and I'll exit. Show VLAN brief. Do show VLAN brief. What we're going to see is all of these VLANs are going to appear here. Now, if I wanted to manipulate any of these, I can give them names, I can make changes, I can specify their particular types, and we'll entertain that when we start talking about things like monitor instances and session monitoring and things. But the main idea here is that we've created X number of VLANs. So let's take a look at our database. So show VTP status. Now what we're going to see, do show, what we're going to see here is that we will see an incrementation. First of all, we now have 13 VLANs, and notice my revision number changed to 8. Previous to this, my revision number, do show VTP status, was 5, if I remember correctly. 3. So let's double check it, make sure I highlighted the right thing. So our revision number is now 8, where previously it was 3. So when we look at this, what we're going to realize is the very moment that I come up here to Cat 1 and I go back into these interfaces, what's going to happen here is if I bring these interfaces back up, the moment that I bring them back up, I'm going to obtain connectivity to my other devices. So I'm just going to say no shut. And what we're going to find is the moment that I return back over here to say Cat 2, where it was previously 3, what we're going to find here is the system is going to change my values. I'm now sitting at 8, and I now see all 13 of my existing VLANs. Now what happened was the moment the system came up and Cat 1 became available to the VTP domain, what happened was all of the devices that are speaking VTP got together. and they said, okay, I've got a database, and that database has a revision number of 3. The other 2 devices came up and said, well, I've got a revision number of 3, so I match you, and the other device said, I have the same thing, 3, and I match everyone else. However, Cat 1 came up and said, I have a revision number of 8. That means I've seen more changes. I've been alive longer, quote unquote, than the rest of you guys. So what happens is that Cat 1 is going to superimpose its database on top of all of the other devices. Now the point here is that this can be problematic for us, because what's going to happen is we're going to see that we have the capability of having this work in reverse, because right now it pretty much worked to our benefit. I went to Cat 1, which was quote unquote the hub of my VTP environment, and I made some configurations. Now what I want to do is I'm going to come in here and I'm going to make some changes. So what we'll do is we'll go over to Cat 1, and I'm going to delete some of those VLANs. So see, do show VLAN brief. And what we're going to do is we're going to take some of these VLANs that we got and we're going to get rid of them. So I'm going to say no VLAN 100 to 600. I'm going to take them all out. Now show VTP status. I know my VTP domain is intact because notice I typed one command and removed a whole bunch of VLANs, but that one command incremented my revision number by a value of 1. So if I visit any of these other devices and do show VTP status, what we're going to see here is that each of these devices are going to share my revision number. That tells me that my VTP domain is operational and holistically functional. Now what I want to illustrate here is the fact that if I come over here to, say, Cat 3, we have different modes of operation. It was being discussed in the chat. What I'm going to do is I'm going to change Cat 3 to where I can't create VLANs. So right now if I come in here and say I want to create the devil's VLAN, VLAN 666, and then I come out, show VLAN brief, do show VLAN brief, what do I see? I see VLAN 66 or 666. If I roll up here to Cat 1, I'm going to see the same thing, show VLAN brief. And we're going to notice the devil's VLAN was made here. All right, now what I want to do is, I didn't want somebody to be able to do that. You know, William got into the system. It had to be a William Phoenix instead of William Virginia, because he's a good boy. He wouldn't do that. But William Phoenix got in the system, and he's creating VLANs, and I want to stop that. So what I'm going to do is I'm going to go down to Cat 3, which is the switch that he's responsible for or working with. And what I'm going to do is I'm going to say VTP mode, and I'm going to say client. All right. Now VTP mode client means now he can't add or delete VLANs. Let's say I wanted to get rid of them. So I said no VLAN 666. Try to get rid of it. Trying to hide the evidence. Well, he can't do it. It's not going to allow him to do it. Why? Because he's in client mode. Now by default, all VTP participants are going to be in server mode. By default, if I change it to client mode, that means that that user cannot consciously create VLANs. And therein lies my crux, my analogy. Because what I want to do here is I'm going to say show, well, do show VTP status. And what we're going to see here is that I have now a revision of 10. Now that means, without checking everything, it's going to be revision, 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 revision. So what's going to happen here is that, let's say, Cat 3 is connected to another device. Let's say we got Cat 6 out here. Just for the sake, we don't have one of those. I'll move my head over here. So actually, I'll try to move my head over here. So what we've got Cat 6 sitting out here. Well, with Cat 6 sitting out here, let's say I receive an update to here. I'm actually going to create it because it came from a server. And then what I'm going to do is I'm going to pass it on to the next guy down the line so that he can add it. That's going to be a really important behavior, because we're going to find out that it's through this method that we create this entire VTP domain that's going to be functional and allow us to create our environment. Now looking at this, you would think that almost immediately that we could have an issue here where if I can't create a VLAN because I'm quote unquote read-only, then how can I pass it on? Well, that's just it. I'm going to take the command, I'm going to process the command, and then I'm going to hand it over to my neighbor. Now here's the issue. We don't have a Cat 6. But what I want to do is I want to go over to Cat 4 and I'm going to kill its link to the rest of the network. And by being able to do that, what I'm going to do is I'm going to go to Cat 4 and I'm going to take a look. First of all, make sure that I have a matching configuration. So did my VTP status increment? Yes, it's 10. So what I'm going to do is I'm going to create some VLANs. So I'm going to come up here and I'm going to say VLAN 30, VLAN 40, VLAN 50, VLAN 60. And what we're going to see is all of these VLANs are going to get propagated. They're even going to appear over here on Cat3. Show VLAN brief, or we'll just go ahead and just show the VTP status. Do. Forgot to do the do. So what we see now, we've got 13. So we're incrementing. If I wanted to see those VLANs, show VLAN brief. Do show VLAN brief. And there they are. It's 40, 50, 30, 40, and 50. Well, I'll go back over here to Cat 4, and I'm going to remove those. No VLAN 40 or 30 to 60. All right, show VTP status. This is going to show that the database is incremented. Now it's 15, my revision. Now, what I'm going to do is I'm going to find my link, show interface brief, or show interface trunk. 19 and 20. So interface range, FAO, 19 to 20. I said range, but I didn't type it. And what I'm going to do is I'm going to shut this interface down. Now I'm going to create some more VLANs. I'm going to create VLAN 500. I'm going to create 501, 502, and I'm going to create 503. Show VLAN brief. There they are. Show VTP status. And what we see here is my revision has incremented. Now, when we come in here, I'm going to do something else. I'm going to say no VLAN 10 to 100. Exit. Show VLAN brief. So now I've lost 10, 20, and 30, but I got 500 to 666. And everything's hunky-dory and fine. And what I'm going to do is, I don't want to have a problem where somebody else messes with my database. So what I'm going to come in here is I'm going to say VTP mode client. Show VTP status. And what we're going to see here is now I have a configuration of 20. And I see that my operational mode is client. So to where now if I wanted to create config T VLAN 999, it's not going to allow me to create it. But the issue here is the moment I come in here and return to my interfaces and bring this device up, what we're going to find is the danger in VTP. And this is one of the reasons that Cisco is really not a big fan of it anymore. That's no shut. So now what we have is we have our configuration where we have our revision is now 20. And if I come up here and I type show VTP status on 1, notice now my revision is 20. Notice now if I come in here and type show VLAN brief, what we're going to see here is that I lost VLAN 10, 20, 30, and all of the other VLANs. Even though Cat 4 was configured to be just a client machine, by virtue of the fact that it still exchanges information associated with its VTP database and its revision number was higher than all of the others, by accident I just completely obliterated all of the lower half of my VLANs operating in my network. Now Cisco said, well, that's not all that great. It's not all that great, especially since there's no real way to protect ourselves from that, because all you got to have is the VLAN, is the VTP domain where you could actually accomplish this. So, I mean, obviously, I could come back in here and I can recreate that. So, let's look at that as an option. So, what I'm going to do is I'm going to come in here and I'm going to say show run. And let's see where our VLAN is, where our VLAN information is. So, we're going to scroll down here. I'm not seeing anything other than just my SVIs. Let's do this. Let's do a show run pipe include VLAN and see where our VLAN data is stored. See, we've got VLANs allowed on our trunk going to Cat 2, But I don't see anywhere in here where it says VLAN such and such, such and such. So it's not really a copy and paste operation. So when we start looking at this, one of the things that we want to make certain that we entertain is where this information is stored. So let's take a look at the content of a file or a storage area called flash. And what we're going to see here is that a database. We have a VLAN database that's stored right here. This is where the information about our VLANs are actually stored. The VLAN.dat file. Now, when you blow your switch configs, you need to delete that VLAN.dat file if you want all of those VLANs to go away. So what you're going to do is you're going to write erase, you're going to delete VLAN.dat, then you're going to reload. And that's going to bring up your devices, and they're going to start with an actual clean start. Now, I've got here William saying, won't get updates from the VTP server until the config revision catches up. Was that in reference to something that I was saying, William? I'm sorry. The idea is he's right. What's going to end up happening is everybody will write to the device that has the highest revision. No changes in the VTP domain will be propagated beyond those synchronization changes until such time that everybody agrees on the identity of the VTP configuration. All right, now looking at this, we now know that the database is stored in flash. We also need to focus on what we need to do I understand, William, thank you. Yeah, William was just pointing it out, but yes, that's exactly what's happening. So when we come in and we start looking at this, one of the things that Cisco tried to do to prevent this kind of configuration was they said, okay, you can buy a switch from eBay, and sometimes it'll say VTP domain is the password, or as the actual configuration. So what Cisco said was, all right, if we want to be able to do this, what we need to do is find a way to protect these devices. So the protection came in the form of authentication. So just like creating a VTP domain, we can actually come in here and we can create a password. That password, for instance, like IPExpert, and then what we do is I'll cut down to the other devices, VTP, password, VTP, password, IPExpert, VTP, password, IPExpert, and lastly on Cat4, config T, VTP, password, IPExpert. The VTP password is not clear text, William. In fact, it's stored clear text. So if I come up here and type show run section VTP, do show. Oh, it's a switch. Can't use the section command on switches. I wish they'd changed that in version 5. So show run. Take a look at this. Spanning tree config, interface configs, base configurations. But I'm not seeing any information in here. I mean, where is the section for my VTP config? Well, it too is also stored in the confines of that VLAN.dat file. This is a list of all of the different topics on the lab. I'm just making sure that I'm touching each one of them. So the thing is all of that information is going to be stored. Now, this is going to be also another thing that we want to make certain that we look at, because by configuring the VTP password, just like was mentioned, what's happening here is we are not exchanging the password. So in this scenario, I have Cat1, I have Cat2, I have Cat3, and Cat4. Now I gave each one of these a password, and that password was IPExpert. So here, 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 and here. Now all of these obviously are connected on this graph. This isn't individual switches, this is graphs. Now what we're going to find is we're actually going to send an MD5 hash between our devices. We have the password stored in the VLAN database, and we're going to send this hash between all of the components that are actually participating on the link and working in VTP. Now this hash is going to be visible to us when we execute the idea of the show IP interface brief. Not do show VTP status, excuse me. This is our MD5 digest. And we need to make certain that this numeric sequence matches device to device to device. Now, I was trying to pull a swift one here because what I want to illustrate is also the point that this is case sensitive. I did I capital P expert on all devices but Cat4 where I just did IPExpert. Now, what if I want to see this password? Well, what we're going to do is we're going to come in here to see the password. We type show VTP password. So in this regard, it's clear text because all we're doing is querying the VLAN.dat file to find the password. It's also going to show us the case sensitivity. So if I go over to Cat4 and do the same thing, do show VTP password, what we're going to see here is I did not use the uppercase P. Now also, interestingly enough, what we're going to see here is an error messages that are being generated by our dear and sweet friend CDP that are going to allow us to recognize the fact that our VTP configs are not the same. So what we want to do is we want to go in here and make the modification or the change to this such that we're going to support it. And in order to be able to do that, that's simple enough. All we do is do VTP password. But before I change it, show VTP status. What I want you to see here is do show. What I want everyone to see is our hash is not the same. So here, let me see if I can click this. And I'll cut back over to Cat1 and I'll just paste it in here for comparison. As you can see, this hash does not match this hash. I know I didn't grab the whole thing. I was just trying to show the illustrations here. So let's see here. No, just saying, isn't the VTP password in clear text? Password is never actually sent between devices. I meant sent between switches. Like if I had a packet sniffer on the link, would I be able to see the password? No, you would see this hash. This hash is exchanged between devices. And what ends up happening, interestingly enough, is I don't know if you guys are familiar with how MD5 hashes are created. A hash is normally based on two values. We have a calculated value, and we have what's referred to as a salt. Now in the confines of this, what's happening is that we are going to use the calculated value. That's the password that we use, IPExpert. Now what we could do is we could use that, but that's interestingly enough not strong enough from Cisco's point of view. I mean, it's odd talking about this in terms of strength. But the thing is that Cisco's looking at this password and saying, well, we need some additional information, and that's where the salt comes from. The salt in this particular instance is actually the revision number, something that's constantly changing on the system. So what ends up happening here is that we're going to take and do a mathematical calculation of the calculated value and the salt to come up with a new value that we're going to use to create this MD5 hash. Now in the instance where I had no password, so long as my revision number stayed the same, the salt was the same, so it was still calculating this value here. It just wasn't interchanging it for the uses of or the purpose of authentication. Now is this a pure or a perfect way to protect our scenarios? Not even close. Not even close. I've seen people hose environments by accident and you think, oh, that's just plain stupid. They should be fired. Well, what ends up happening is when something breaks, people get in a hurry. And a lot of times the equipment that you put into your network was equipment that you pulled out of your network that you decided to repurpose somewhere else. Use it for a lab or use it for some other component. So what ends up happening here is many times they take a piece of equipment and they shelve it and they start using it, and then somebody may grab it to do things like study for the CCIE on. And next thing you know, you've got a database for a VTP that's like 1,000 items long because they keep changing it and they delete the VLAN.dat file. So when that happens and then somebody grabs it and plugs it back into the system without thinking about reconfiguring it, bam, you blow your entire layer 2 environment. Now another way to get around this is that another solution that Cisco have, and that is to change the mode, and someone was talking about it earlier, and that is to alter your mode to transparent. Now transparent is great and wonderful, but it's not the cure-all to all of our ills. So if I wanted to come in and I wanted to do a configuration such that I need, actually what I want to do is I want to change the config here. Right now what we're doing is we're operating in a graph. The graph is just the illustration of how our devices are interconnected. Right now, it's just a hub and spoke where we've got Cat 1, we've got Cat 2, we have Cat 3, and we have Cat 4. Now right now, what we're doing is we're connected from here to here to here to here. What I want to do is I'm going to change that. I'm going to connect this into a chain, a daisy chain. So when we go through and we make this work, what I'm going to do is I'm going to take any link that I have here and I'm going to break it. So the easiest and fastest way for me to do that for the purposes of this class is to come in here and turn this into desirable. Now when we start looking at it and we set this up, all I'm going to do is I'm going to cut over to Cat 4 and I'm going to make that change. So I will grab my arrow, Cat 4. And what we're going to do is I'm going to make those changes. So it's going to be interface range, FA0, 19 to 24. And what we're going to do is we're going to say switch port mode or switch port trunk and cap. I'm going to say .1Q, switch port mode dynamic, switch port trunk dynamic. What am I doing here? Switch port mode dynamic desirable. Sorry guys. So let's see what happens. Show CDP neighbors. What I want to do, show CDP neighbors. I want to kill all the interfaces pointing to 1 and 3. So it's going to be, no, I want to kill them Cat 4. Get rid of the one pointing to 3. So interface range FA0 21, 21 to 22, shut. Interface FAO 19 to 20, shut. Range. So 5 months of NXOS has practically destroyed me. Shut. So let's check our config. So if I come up here and say show CDP neighbors, should be connected to Cat 2, Cat 3. Well, I did it backwards. Crap. That's all right. So that means this link right here is gone. So right now I've still got my daisy chain. I'm connected to 3. Let's go up to Cat 3 and make sure I'm connected to 1 the way I was supposed to be, which we were. Show interface status. So 3 is connected to 1 and to 4, but I don't want the connection to 2. So what we'll do is we'll get rid of that. We will say interface range FAO 19 to 20, shut, exit. Show CDP neighbors. Should be connected to Cat 1 and Cat 4, and Cat 1 should be connected to Cat 2. So looking at this right now, what we have is hopefully the daisy chain that we were talking about. Now what I want to illustrate here is I'm going to come over here, I'm going to make certain that everything in our config is operating as a server first. Server, server, server. And then what we're going to do is we're going to change this one right here, and we're going to change him to what's referred to as transparent. And we're going to observe the differences. So first of all, let's look at that. So we will come up here, make certain that everything is configured the way we want it. So we'll start at Cat 1, VTP mode server. Okay. VTP mode server. VT mode server. And lastly, VTP mode server. Now what we're going to do here is I'm going to cut back over to Cat 3. Cat 3 is going to be our guinea pig for this. So what I'm going to do is I'm going to say VTP mode transparent. Now something interesting just happened. Let's take a look at this. Show VLAN brief and take a look at the listing of all of our VLANs. Well, we've got 500, 501, 502, 503, and 666. and nothing else. But now when we do our show run, what we're going to find is that the information in our system regarding our VLANs is now actually inside of our configuration. So the first thing that we need to understand here is that VTP transparent mode copies the information into the running configuration of our devices. So if I come in here and I say, let's create VLAN 20 and 30 again. So we'll say VLAN 20, VLAN 30, we'll go ahead and create 40 and 50. Exit. Show, run, pipe, include, VLAN. And what we're going to see here is here is a list of all the VLANs that were created. Now what we want to point out here is that if we go over to Cat 1 and do show VLAN brief, and press enter, what we're going to find here is it didn't create those VLANs. Why? Because we're transparent. Transparent means that we're not going to pay attention to VTP. We're not going to do anything that VTP tells us to do. So what I want to do in this particular instance, I'm going to create some more VLANs over here. I'm going to say I want to create 777, VLAN 778, and VLAN 779. Now what we'll do is let's cut over to 2, do show VLAN brief, and take a look at the output here. And what we see is we see 777, 778, 779. Let's cut over to Cat 4, do show VLAN brief. And we should see the same thing if everything's configured. Well, I don't see anything here on 4. So what's going on here? So show VLAN brief. So the interesting thing here is what's going on. So let's make sure that our VTP config's not hosted. I think I need to just change my VLAN, my address here, my password. Show VTP status. Excuse me. All right. So show VTP password. Did I change it? No, I didn't. See, that's my problem. So here, config T, VTP password, and it's going to be IP capital P expert. All right, now let's take a look and see what we got going on here. So show VLAN brief. Do we see those bad boys in here now? No, we don't, but we might be able to force an update. Let's do this. We'll come over to Cat 1 and say VLAN 900. Exit, no VLAN 900. See if that forces an update. Now what we'll do is we'll double check here, show VLAN brief. Do show VLAN brief. And there we go. We see 77, 78, and 79. So again, all I did is I left the password off. Therefore, it wasn't part of my operational VTP domain. Now, when we look at what's going on here, let's take a look at Cat 3. Show VLAN brief. Now notice, it didn't take the configs. So there is no 77, 78, and 79. However, interestingly enough, what we see here is that it passed it on. So we did the configuration here on Cat 1. The update went to Cat 2. Cat 2 installed 77 all the way out to 779. We went down to Cat 3, but Cat 3 is in a transparent mode operation right now. So I did not apply any of those that update information, but in turn, it passed it on to Cat 4. Cat 4 installed it in its table, and it has 77779. Now what I want to do is I want to illustrate something here. We're going to create an SVI just for the purposes of testing, and we're going to put it in 777. So we'll come up here and I'll do that on Cat 1. Config T. Interface VLAN 777. IP address we'll say 172.16. And we'll say 0.7.255.255. No shut. We'll come down here to Cat 2, do the same thing, config T, interface VLAN 777, so it's going to be IP address 172.16.08, class 3, or not class 3, but /24. Fat fingers all over the place today. No shut. Interface, we don't want to create the others. We'll do the same thing on 3. Config T, interface VLAN 777, IP address 172.16.0.9/24. And lastly, cat4, config T, interface, VLAN 777, IP address 172.16.0.10/24. No shut. And let's take a look at our configurations here. We step in here, like I said, what's happening is we're passing the information. And that's by default what we want. Now, we can run into some situations here. So what I want to do is I want to try to illustrate reachability. So what I'm going to do is I'm going to cut back over to cat1 and see if I can ping 172.16.0, and I want to ping 2, so that's going to be .8. Let's see what happens. See if I have reachability, and I do. Let's see if I come over here and I can ping 172.16 cat3, which is 9. Hit enter. Let's see if I can ping it. Now remember, cat3 is the switch that's operating in transparent mode. And this begs the question, what version of the system are we operating? So show VTP status. And what we're going to find here is that when it comes to VTP, we're currently operating in version 1. All right, now we can change it, but let's just look at our behaviors right now first. So cat1 was unable to reach 3. So looking at this, right now, remember, I've got this thing daisy chained. So I've got cat1, or I'm sorry, I got cat2. I've got cat1. I have cat3. And I have cat4. So let me ask the question. I'm testing on cat1. I can reach the 777 interface on cat2. I cannot reach it here on cat3. Will I be able to reach it on cat4? Will cat4's address be pingable? So will I be able to reach 172.16.0.10? Any takers? VLAN 77 will need to be created on cat3, but need to have the VLAN even if forwarded the VLAN data. Well, let's see what happens. So let's go back over to cat1 for our testing. And remember, we were pinging 10 or 172.16.0.8. We pinged 4. We could not ping 3. Let's see if we can ping 10. And we're not going to be able to ping 10. Now, why can't we ping 10? Well, it has nothing to do with VTP, but everything to do with spanning tree protocol, something we haven't talked about yet. So what we need to recognize here is in order for me to move information across these links, I must have spanning tree running in a forwarding operation. Can I have spanning tree running in a VLAN that doesn't exist? No, I can't. So with cat3 configured such that it does not have VLAN 777, I cannot forward information through it or have information reach it. Now, I was beginning to start a conversation about pack priority. Pack priority is a value that's used to represent whether or not a packet is going to be locally processed by a router or a process running on a router. Now, when we go through and we start looking at how each of these devices are connected, what we need to realize is we've made a black hole right here because we do not have VLAN 777. So I'm going to simply go there and create that VLAN. And then what we'll do is we'll see if that actually mends or heals our problem. So VLAN 777, exit, show run pipe include VLAN. And now we have 777 on the list. So if I return back up to cat1, if I were to try to ping 9, which is cat3, let's see if I have reachability. What am I waiting on, guys? It's not working. Does that mean it's broken? I'm waiting on something. What am I waiting on? We've already discussed it. I'm waiting on convergence. So I'm waiting the 15 seconds learning, the 15 seconds of listening and learning. And now I should be able to ping 9, and will I be able to ping 10? And actually you can reach 10. So VTP is significant only in the context of ensuring that I have a forwarding instance on an interface per VLAN because if I don't have the VLAN, I cannot forward or send information. Now, oddly enough, it's really funny because remember, we didn't have the VLAN, but we were able to propagate it, again, because we were using the concept of VLAN 1. So in this instance, it would be 30 seconds because I didn't bring the interface up from start. I didn't restart the device. You only go through the 20 seconds of blocking after an initialization, i.e. I've brought the interface back up and made it running. So the only thing we're doing is the forwarding delay. 15 seconds listening, 15 seconds learning. Now, looking at how this is interconnected, we have a fully operational environment. We're running security with regard to authentication, if you can call it security, on our VTP process. We've demonstrated how this can be a really boon or significant boon to us. But what we also want to pay attention to here is another element. And that element that I want to really look at is going to be the idea of VTP pruning. Because what we did before, we went in and went on an individual link on our trunk, and we used the switch port trunk allowed VLAN or remove or whatever key feature that we wanted to be able to restrict the number or the type of VLANs or the specific VLANs that we wanted to allow across a trunk. Now, we can do the same thing using VTP, which is a very, very handy tool, but the problem is it too can bite us in the rear end. So let's take a look and see if we can't build a scenario where I can actually make this illustrated working. So first of all, how do I turn on VTP pruning? Well, I go to any switch in my topology that's operating as a server, and what I do is I just simply type VTP pruning and hit enter. And what that's going to do is that's going to turn VTP pruning on. So if I come up here and type show VTP status, what am I going to see? I'm going to see the list down here where it says VTP pruning enabled. Now, the moment I enable it on a specific server inside my VTP domain, do show VTP status, what we're going to find is it's going to be enabled system-wide. Now, let's look at Cat 4. Do show VTP status, Cat 4, VTP pruning enabled. What's going to happen on Cat 3? Will pruning be enabled on Cat 3? Do show VTP status. I'll wait for somebody to chime in. Will it be enabled on Cat 3? Remember, Cat 3 is in transparent mode. Notice it's disabled. It's disabled because we're in VTP transparent mode, which means we're not going to be processing any messages that we're going to be receiving from our server. So if we look at what just happened here, what we're going to find, let me grab my eraser. What we're going to find is just like I said, we have Cat 3 interconnected to all of these devices. So the message came from Cat 1 to turn on VTP pruning, to Cat 3 to turn on VTP pruning. We ignored it. We didn't process it at all, and what we did is we sent it to our neighbor. So Cat 4 is doing it, Cat 3 is not. So Cat 3 is not participating in pruning. So here's the situation. What happens if I create a new VLAN? All right, I create a VLAN, let's say, well, we already used 777. So let's use 777. That way we're not wasting a lot of time creating a lot of new information. So in this scenario, we have VLANs. We have 777 all the way across the board. So when we look at this, what I want to illustrate is this. Show interface trunk on Cat 3. Now Cat 3 is our transparent bridge. Now notice right here, notice it says spanning tree, forwarding state, and not pruned. So I'm not pruning 20, 30, 40, and 50. Why? Because they're configured on my system. Now look here, it says VLANs allowed and active in the system, but notice I'm not pruning. So VLANs in spanning tree, forwarding state, and not pruned. So the ones that are in forwarding state are these on each of my given links. Now it's this idea of pruned that we're talking about. So I'm going to go ahead and create a new, clear this off. So as we go in and we start looking at how this is set up, let's start with Cat 2 and we'll work our way over. So when we look at this, I want to do some pinging. I'm going to say ping 172.16, and I want to ping 7. I want to ping 8. That's me, sorry. I want to ping 9. and I want to ping 10. So we've got reachability here. Now here's the situation. Let's take a look at what happens between these devices. So now on Cat 2, if I create a new VLAN, config T, and I say VLAN, and let's say I want to create VLAN 1000 just to make it stand out, and I'm going to name it. I'm going to say test VLAN. Exit. Show VLAN brief. Now what we see here is that we notice we have this VLAN, the test VLAN. Now let's cut over here to Cat 1 and take a look. Do show VLAN brief. Do we have